Welcome to our new Analytics and Data Community TechCast. We are going to have today a great session by Albert Godfrind about using a spatial index to find the nearest path. It's a very, very funny and entertaining and very useful session that we're going to see. First of all, my name is Edo Vice Cameraman. Everybody call me Edo. I'm part of the board of the Analytics and Data or community and ACE director. So welcome everybody. And let's start with our session. I'm going to talk a little bit about us, about our community. So Albert, if you be so nice to, yes, thank you so much. So we have this TechCast, as you all probably know, twice a month. This TechCast, we have all the TechCasts recorded, and you can find information in our YouTube channel. We're going to have our TechCast days, which is a quarter. We do it quarterly in our 3 days of very great technical sessions. 1 day for Analytic Plus, another day for machine learning, and another day for graph or spatial. So May 24 to 26, book this time because we're going to have these amazing sessions again. Perfect. And the next slide is going to show you about our merchandising. So it's, Mother's Day in the corner. So if you have a techie mother, that would be a great present for her. So show your tech side in everything you do. It's our motto. And visit our store, NWC store at nwc.org. Again, TechCast Demo Day. One thing that I forgot to mention is all these tech sessions in our TechCast Demo Day are going to include demo. So it's going to be very, very, very useful and very practical. So please join us. Okay. And if you want to be part of the community, if you're not part yet, you can talk with us in our Slack channel. We have also newsletter, and you can have here the links that Carrie is put it in the chat for all the social media, LinkedIn, Twitter, Facebook. So join us and be part of the conversation. Okay. But well, right now, before starting, please submit your questions because you're going to have, I assume, very, very a lot of questions. So please submit them in the Q&A box, okay, not in the chat box, please. And at the end, we're going to read the questions so Albert can go through them. So Albert Godfrind, ladies and gentlemen, he's a spatial and graph solutions architect. He has more than 20 years of experience. He has a huge history of working with the spatial. He's a pioneer on this, but I will let him talk about himself first. So Albert, the audience is all yours.
Okay, thanks a lot, Adel. So again, welcome everyone. I said, yeah, I've been with Oracle for quite a while, and actually that's me in IT for a long time. In fact, all my career has been in IT, so I've not even done any other thing than IT, which maybe is weighing on me in my daily life, although I'm not yet to the point of I would offer IT merchandise to my mother-in-law, but who knows, maybe she would like it. So I've been with Oracle forever. I've been working essentially on geospatial topics and things related to geospatial. I'm also the co-author of that book on Oracle Spatial, which is also a bit dated nowadays because it goes back to version 12, etc. So, but then again, things have not really changed that much. They've been changing the implementation details and performance, but lots of it is still valid. So if you buy that book, you contribute also to my retirement fund. Yeah, and so also graph. For a few years now, I'm also doing much work with our property graph technology, which is really separate from spatial, but there are still some places where they could fit together. So today we're talking about that topic, finding the closest path. If you remember the picture we had on the first page with these guys looking lost and looking at their map. Well, yeah, okay, maybe, I'm not sure what they're looking for, but they might be looking at it for the closest spot, but a map might not be a better idea. And nowadays we have things like smartphones and tablets and IT support. And so the whole idea now is to actually use what Oracle has to offer, so the spatial database, but also tooling like Spatial Studio about that. But still, let's go through, and so this will be a story in 4 acts. And Act 1 will be the fundamentals. And at some point, we need to go back to the fundamentals like this, because at the end, what is spatial data? We talk about spatial data, and what is it? What is it not? That reminds me of one time a while ago. It's actually now maybe a long time ago. I did some workshop actually in Poland, and then so I started talking about spatial and Oracle and all of these things, and then we had a break at like 10 in the morning and then one guy said, yeah, I'm a bit, what you're talking about, not really what I expected. In fact, what you expect was I was going to talk about Oracle in space, which is not what this is all about. So the spatial doesn't mean that. They probably, is Oracle running on the space station? I don't know, but there's probably some Java running there. So in a way, maybe there is some bits of Oracle running up there. I'm pretty sure there is. There might be some. But anyway, so this is spatial, but really it's down at Earth. It's on the ground. And so what is spatial data? It is business data that contains or describes location. So there's some location, it's some thing that says this is here on the globe, on the ground. So obviously things that you see on maps, geographic features, so road, the rivers, the parks, and everything you see on the map, but also things like technical things, so assets, cell towers, transformers, visible or invisible. That could be invisible, could be buried cables or sewers or water pipes underground, for which we need to know exactly where they are, because you want to dig up and fix some pipe somewhere. We really need to know that it's actually here and not there, because if we dig up here, well, no, and there's no cave, there's no pipe, well, it's wrong. It's just off by 50 centimeters. No, that's bad. It's actually here. It would close and dig in. So it's important to have accurate information for these things. There are also abstract data, things like sales regions. Now, sales regions are not painted on the ground, just like customer location. There's no flag there. Now, when you look at the map, you see, well, there's a flag. Yeah, of course, there's no flag there. There's also nothing that indicates postal code boundaries or street and addresses. So that's a part of spatial data, essentially anything which has some kind of location. And why did we actually start this a long time ago? Because this is not really something new. We started doing this actually in Oracle version 7. Not like a long time ago, really long time, like 30 years, a long time ago. Then we switched to Oracle 8, Oracle 8i, etc. And then things started being more easier to use and more useful as well. And why we do that? But because we observed that pretty much every database of our customers, not all of them, but the vast majority of them, have got some kind of data which has some spatial aspect. If you think about it, you run a bank, you have customers have got addresses, you have branches, they have addresses, ATM, they have addresses. And this is a form of spatial location. It might not be usable as such to show it on a map, but if you turn that into XY coordinates on the map, then you can start doing interesting things like how many customers are living more than or closer than a 5 kilometer radius of all my branch, and maybe find out blank spots where you don't have a branch, and you have customers but no branch. So maybe so time, location is a universal key, just like time. Okay, location says things are nearby. Time says they happen close by in time, one after the other, and there are some. I think one law of geography says that things that are close to each other influence themselves more than things which are far away from each other. So, okay, it's a key. That's what it is. Now, here we're talking about the Oracle database, and we need to be able to manage spatial data. What does it take to be able to manage spatial data in a database, or in fact any data in a database? Well, we need a data type to store it. For things like salaries, we'll use a number. For name, we'll use a string. And the data. For here, what spatial is a bit complex. Like, for example, the shape of a building has lots of points that describe it. So how do we do that? Well, we're going to use an object type for that, a specific object type. Your database since version 8i is actually object relational. And so you can use objects. Now, people don't really use that in an object database, but it's very useful to actually define a new data type with specific behavior. And that's what we do. So we also need to extend the SQL language because we need to be able to say, well, find things which are within some distance or things which are intersecting each other. And so therefore we need specific operators, so SQL operators. To search data, we must have indexes. Without indexes, well, we need to search everything. Like we have a customer table and with 10 million customers. We want to find customer 42. If there's no index on customer ID, then we have to scan the whole table. Same thing for spatial data. We want to find out everything which is in that area here. Well, then we must have some kind of index which isolates things that require me to read everything. So we need domain-specific indexing. And that, again, is something which is provided by database. And finally, we need some functions to process data. For numbers, if we take two numbers, A minus B, we get a difference. Two dates, A minus B, well, we get the difference in days. Now, a polygon minus a, what does this mean? Well, it means actually cutting out, use one to cut out from the other. And so we need functions to do some things. So that's what we're going to do. And we'll see what these functions are and how they are, how we use them. All right. Then queries, going back to queries, doing spatial queries. Well, there are three fundamental kinds of queries we will do on spatial data. One is things that are connected to each other. So return shapes having some spatial relationship. For example, all the properties which are located in a flood zone. So we have a database of flood zones. We record all the floods year after year. And we know this is a lot of floods here. So that's a flood zone. Which properties are in there? Very useful for insurance, to determine the insurance premium, or maybe we shouldn't even build there in the first place. Now, restricted areas, security. There's an area here. I want to know whether a vehicle, whenever a vehicle enters and then leaves the area, again, things are interconnected. Then there are things which are based on distance. How far are things with each other? For example, find all the pubs which are within 500 meters of my hotel. I have location, I have the pubs. Draw a circle and get all the pubs which are inside here. All land passes from a river. And then there's proximity. Not the same as distance. Distance is about things which are within some certain distance. Proximity is more about give me the nearest. Find the 3 nearest restaurants of my current GPS location. And they have to be Mongolian restaurants. Well, okay, they might be far away. Maybe the nearest Mongolian restaurant is really in the next town, like 20 kilometers away. Still, it's the closest. Okay? So we want to find that out. So these are the three fundamental operations, and we're going to try and play with these things. Who's using that stuff? Well, a lot of it is public sector. That's what is associated with something that is called GIS, Geographical Information Systems. You may have heard that term. So public sector, people who deal with land use, land occupation, taxation, cadastre, planning, emergency services, reachability analysis, for example, finding out the area that people from a hospital or a fire brigade can reach in less than 10-minute drive time, to know who will actually serve in this particular emergency and these sort of things. Utilities, of course, with all the infrastructure they have, cables and pipes. But then there's also things which are not so much GIS. They deal with spatial data, but not really fundamentally, like location-based marketing, geo-marketing, site planning. Where should I place my new store? What should I sell in that store in correlation with the demographics of the people in that area? Should I sell, expensive goods, or should I sell cheaper goods and these sort of things? Again, so targeted marketing, risk zone analytics for insurance, and then the whole consumer thing like friend finder, guidance, etc. And there are many more usages. So there are these sort of two different markets in a way. One is the classical GIS market, and then there's the more like retail financial services, which is a different market. The classic market is something that is covered by the GIS vendors, the ESRI and other traditional vendors. In this context, what we do, Oracle, is provide the infrastructure for these GIS tools to plug in. For retail financial services, this is something we can do ourselves. So we have pretty much all the tools we need for that. We have, we talk about Spatial Studio, we have mapping libraries, we have Oracle Analytics, for example, that can use maps as well. And so this is largely done with our own tools without really needing GIS tools, at least not fronting customers. And here's an example of one of these deployments called Allfront Media. Allfront Media is a US company that manages these big billboards you see. If you've been driving around in the US, you see it's really big. They're not so common in Europe. I mean, you see big, but not the big ones, the real ones with a pole, and then you have these massive, big billboard. And while they are big, they are large. And so what happens when there's lots of wind? And that happens in the US. We don't see that much in Europe, although we see a bit more nowadays, but still the big storms, the hurricanes that flow, that come here. For example, here on that picture, we see the footpath, the path of one of the hurricanes some years ago that went over Florida. And the area around it is the, well, I'm not sure what it is. I think it's coming anyway for the weather report from NOAA. And I guess it must be something about wind speed and where things are at risk. And the dots here, well, they're all the billboards that Allfront Media has. The ones in the middle, well, they're the ones which are at risk of being put down by the hurricane. And so knowing that in advance of time, we can maybe do things like some of them are maybe removable, we can take them down, or we can actually start planning for how much money we'll have to pay because of damage that this thing would be caused. Would be good. Look at this one here. Imagine this thing falling down, and the car is coming up. So knowing this sort of thing is important about revenue structure, minimizing operational costs. So very simple application, not really GIS, and that's actually been implemented using Spatial Studio and Oracle Autonomous Databases. Another example is this one that's close to us, close to us. It was recent, and the other one is also very recent, but this is recent. It's the COVID crisis, where pretty much everybody wanted to know, where are my COVID cases? Where are they located? Where are they? Most of them, and what's happening with the spread of the virus and of the sickness. And so that was put up in a very short time, like 10 days, by essentially volunteers in Finland, a team at a company called Miracle Oy, using Apex and Oracle Spatial. So not Studio here. This is using Apex. Apex is one of the tools that we have that also has native mapping facilities now with the latest releases. And it was very popular, and people actually looked at this very, very much to find out what was happening. So these are two examples of the kind of application that you can build using our infrastructure. Act 1, Act 2. Now it's time to click and point and find out that nearest pod. And so let's see how we do that. And for that, we need tools. We need tools, and the tool we're going to use for that is called Spatial Studio. Spatial Studio is self-service spatial analytics. Sometimes we are asked, well, how do you compare Studio with ArcGIS or QGIS, QuantumGIS, and open source GIS? Well, it's very different because QuantumGIS, ArcGIS, these are for specialists. In fact, if you look just at a screen, and an ArcGIS screen or QuantumGIS, you see lots of buttons. It's like an aircraft board with lots of buttons. And what do they do? Well, here we don't have that. Here, this is for non-specialists, for normal people that want to play with maps, understand data spatially, and then manage the data and do some processing. And so it does essentially three things. One is managing your data and enriching it. So data ingestion means that you can now upload data in our database, upload spatial data using structure like the ESRI shapefile or Geojson or others like that, and enrich them as well. That would mean I have my existing customer table or my billboards. I have the address of where my billboards are, or my brand, my ATMs, and I want to do this spatial processing, show them an app. Well, that requires a process called geocoding. Geocoding is the process that will, in this case here, take the addresses of my customers or stores or billboards, and from these addresses, compute or return X and Y, so spatial coordinates. Studio will do that. It will actually use our own services we call e-location that are available online to our own applications, only to our applications. So Apex can do that as well. OAC is using this thing to get maps. Transportation Manager also uses these services for locating delivery points in warehouses, and not really just tracking the trucks, but just planning routes for the trucks. So geocoding, indexing. Then, of course, I can do maps. We'll see some examples of how can we actually make maps in a very easy way and understand where my data is. And then finally doing the processing. The kind of queries we've seen, like find everything which is within distance. Well, the pictures that were actually coming from Studio, because what it does is self-service, no code for geospatial analysis. Now, why did we make Studio? Well, because and that is something we introduced, I think, in 2019. So it's fairly recent, maybe 18, I think 19. Why do we do that? Because before that, all we had was a toolkit. You had to do something like find all the pubs which are now and say, oh, yeah, sure, easy, write this SQL statement. Well, that's not what people do. No, they don't do that. Some maybe data scientists will do, but not your regular user, not your mother-in-law, and your mom will not do that either. So they will like something simple. And so that's why I said, well, we need to have something simple and easy to use that does all this. And so essentially, if you look at this thing here, you see things like this: return, shape, and contain another. SDO contains. SDO contain is the name of the spatial operator. So what this really does is generate the SQL statement and execute it for you. And you can even see the statement. So you can actually take the statement and then run it in your own application. Lift it from your from here, copy paste, put it in your Python code or in your Java code or SQL developer or any SQL application. So that's what it does. So setting up Spatial Studio is free. It comes with without any licensing requirements. It does require an Oracle database, however. If you don't have an Oracle database, you won't be able to use it. So it does not, it depends on it also. Well, first of all, it only can take data from an Oracle database, so that's that. And also it uses an Oracle database to maintain its repository of information, of projects, of data sets, etc. It's available for download here. I think you will find the URL in your chat. It's available in two packaging. One we call Quick Start and one we call Spatial Studio. The Quick Start is essentially your private desktop deployment. If you compare that with Oracle Analytics, there's Oracle Analytics Cloud and Server, and then desktop. That would be like Spatial Studio desktop. Spatial Studio, the second one, is really an EAR file you deploy in your own WebLogic environment. There's a third deployment, which is the cloud marketplace as well, so which would be a bit like Oracle Analytics Cloud. So if you want to play with this, just download Quick Start on your desktop, whether it's a Mac, Linux, Windows, doesn't matter. This is pure Java. The first time, and so you will be able, you have to connect, you give your name, password, and that's the standard password. The first thing you need to do, the first time you connect to your Studio server, you will be asked to provide a database connection to a database connection, a username, a schema in database that will be used as a repository. Because Studio, once you start it, you will see, in fact, I'm going to show that to you, talks about data sets. So there's a repository of data sets. There are projects and configuration projects. And so it needs to keep track of this configuration. And what safest place to keep this done in a database? Now, we could, of course, use some config files, but why not put it in a database so it can be shared by others as well? So when you start up also the first time, you get this thing. So there's some videos you can watch here about overview, what it is, preparing data, using it to analyze, and you get the fundamental steps: create connection, create data set, create project. So connections, well, you have to connect to a database, but you can connect to multiple databases. Like in my example here there are just 3, but in reality, in my environment, I have like, I don't know, 10, 12, maybe more connections to autonomous databases, local databases, various schemas in all these databases. I'll show you that. So there's connections. There's data sets. Now we use the term data set because it's sort of a common term in geospatial data or in data science, data set. Now, a data set really means a table. So each of these corresponds to a table in a connection. So here, Scott, Graph, Scott, these are connection names, Spatial Studio. Oh yeah, there's one called Spatial Studio. That's a special one. That's the one that you defined initially to hold the repository. You can also use that for data, of course, but well, I think maybe I like to prefer to keep this separate. You have Spatial Studio just for the repository, just for the few tables of the repository. Okay. Yeah, so these are my data sets. So it's essentially a reference, a dictionary of all the tables that have been loaded. So these have been coming from either files I've uploaded or just tables I took from a schema. So I have to, if I want to play with a table in a schema, I have to say create data set, which really just takes adds a pointer in a repository to that data set. We'll see examples of that, maybe not. But then projects. So what's a project here? A bit like OAC. What's a project? It's a collection of data with dashboards. So here it's a collection of data sets with a map or multiple maps. There could actually be multiple maps on a dashboard. So here we see example of like airport. That's about airports. With airport, there's US data. VLib. Well, this is something I did about. VLibs are free access bicycles in Paris, and so they talk about the stations and how many bikes are available with different colors, and there's some world data, etc. So a project can be published, which means that you get a shareable URL that you can actually include and pass to other people so they can actually use the same thing. And then there's the currently active project, the one you are working on at any point in time. And this is where you see things like the data set that have been added to this project, which ones are on the map. There's the map, there's some tabular window as well here. So that's what you play with essentially. So you run analytics and you get this circle, these buffers that select things. You can see here something like I think the red dot here must be a hotel. And that must be a circle of, I don't know, maybe 1 kilometer, yeah, maybe. And then the dots here, the blue dots are probably pubs or restaurants within some distance. That's what this is about. All right, so yeah, now we have the tool, but we need ingredients because we said, yeah, let's find pubs. Okay, but for that I need a database of pubs or a table of pubs. So here, what I did to make this work is to collect that data from internal data we have from a company called Here. Why? Well, because our services, what I said, e-location services for geocoding, for example, or for routing as it is used by Transportation Manager, or for maps, is actually something we are getting from a company called Here. Strange name for a company. Try and find Here in Google. It's not so easy. You'll find lots, but hard to find out. It used to be called Navtec, but they changed their name to Here. And so they are one of the global providers of geospatial information for car navigation, in-car navigation. If you're driving maybe a German car and there is your in-car navigation system, there's a good chance it will be Here data, or could also be TomTom data. So TomTom, as you see here, is the other product. So why do I use this? Well, because I'm a bit lazy. I just took the data from there, to pubs, hotels, restaurants. Also, I'm not going to talk too much about that, but I also included admin boundaries. Now, notice this is, Powiaty, Gminy. What's that? Well, that's actually Polish. Now, why Polish? And PL stands for Poland. So we said, show me the nearest pub. Well, actually, it's pubs in Poland. So if you know Poland, that might be useful. If you're not in Poland, well, that might not be so useful. But then, of course, you can get your own data from other sources. Like, for example, OpenStreetMap. OpenStreetMap is crowdsourced. So it's people like you and me who collect the information and feed a database a bit like Wikipedia. Right? So, except for spatial data. There's also GeoName, which has interesting places. Geographics for Europe. There are lots of sites like that. I mean, if you want to find out the address of all the restaurants in, I don't know, like in Portugal, for example, that will be available from these places. And this, OpenStreetMap is free. It's open source data as well. That's what it says. OpenStreetMap is open source data. All right. So we have the data. Notice we have some as CSV files, as spreadsheet, as JSON, and we can then use it. So now we have the tool, we have the ingredients, we can start cooking. So let me start Spatial Studio here. So I'm not starting Spatial Studio as such. Spatial Studio has been running on my laptop. It's actually running locally on my laptop on my Mac here. But I need to connect. So here, yeah, this, yeah, and then here, yeah, fingerprint. Okay, good. Login. All right. All right, there you go. So this is my own environment. Now, of course, if you start running this, you will not get all these projects. It's empty. We do not provide sample projects. Maybe we should. A bit like OAC gives you some sample data. We should do that. We should have some simple sample data in sample project instead of having a blank sheet. But here it's sort of going from a blank sheet, because what we are going to do now is, first of all, load some data. So here you see I have, as I told you, I have lots and lots of data sets here. We actually need to do something to bring some order. No, in reality, in real life, you probably would have not that many assets. Now here I'm just many because I do all sorts of POCs and tests, etc. So and they accumulate. So it would be nice if we could actually have some kind of foldering or to make it. But anyway, that's so let's look at so let's create some data sets. So create data set gives me this thing which says which lets me do, well, essentially two things here: uploading from files, and that's what I'm going to do here because I have a CSV file. I'm going to upload that, but I can also now take data sets from a table. So say which connection, for example, here I could go to one of these and then pick up a table, and that will actually bring the table in my repository. There's no data movement, just a pointer from our repository to that particular data set. So JDBC connection, username, password, etc. I mean, the password will be in the connection anyway, and will of course stored in an encrypted way in the database. So let's go for file upload, and what's the simplest way? I guess I'm just going to do this. I really can actually also drag and drop, but I'm going to do it this way because it's actually easier here for me. So I'm going to go to files. Where is this file? Events. Sorry about that. It's actually conferences, and it's actually this, and it's actually Poland, and it's actually this. So yeah, the other reason why I took Poland is also because I'm lazy. I have that data. I did this sort of thing about, you saw it in September last year. So now why should I go and do it again for another country? Because why not Poland? So let's take this. So let's take here CSV file. So upload that CSV file, and then say create. There's one more here. So it shows me a shot of the data. Again, like OAC does the same thing. I can adapt the data types if I want, but it's it figures out, a bit like autonomous database loading. It figures out which types are here, and what we see here is that we have longitude and latitude, okay, in two numbers. So we're going to upload that into a connection I created called AND TechCasts. Submit. Okay, so it's uploading. While this is cooking, I can try and do another one, which will be, I think, this one. Which one did I upload here? Not the hotels. Yeah, I think that's the one I want. Okay, so same thing. This is a spreadsheet, so same thing. We recognize what we have here, and the same thing. We have also long and lat columns. So which connection? Again, in AND TechCasts. Let's submit this one. Let's upload. Yeah, submit. It's cooking, and then create another one, and that the third one is going to be slightly different. It's JSON. JSON. Yeah, because geospatial data comes in multiple file structures and file formats. That's been a problem since the beginning of the invention of GIS. You had lots of companies, and each one would have their own format. And still today, there are lots and lots of different formats available. And so one big issue is, interoperability. Show me your data, but I can't read that file. Give me another format. And so some common standard formats have been developed. One is very old. It's called the ESRI shapefile. It's not very semantically rich. Then more structured format have appeared, well, I guess beginning turn of the century, That's GML based. Remember the time everything was GML, XML, sorry, not GML, XML. And the format is called GML, Geographic Markup Language. And then more recently, we have something called Geojson. So JSON for geospatial data. That's what we have here. So we have a Geojson file. So you see it talks about feature collection and features. And somewhere in there, you will see coordinates. You see type point coordinates. And so this is good for processing any kind of data. So not just points, of course. And here we talk about not a point, but complex shapes like lines and polygons, like so building outlines and everything like that. So here we are going also to say uploading techcasts, and what we see here is the problem with JSON is not always good at. Oops, sorry, do you want to do that? It's not always good at detecting the data type. Like for example, here house number, it's a string. Well, I may change it to number. It's not important anyway. But the postal code is a string. This 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 is a string. So yeah, and restaurant ID is probably also a number. But again, it doesn't really matter. All right. So submit. So it's still uploading now. I switched screens, but it's uploading, and now they should all be there. So let's see where they are, and get the latest one. And so here we see hotels and pubs. I guess the third one is still uploading. We can see there's a moving blue bar over here, and they are not really usable. Okay, it says warnings, no, view details. Well, so what are they? Let's look first at pubs here. Well, first of all, we need a unique, not numeric, but a unique single column key. So we not really use yet multi-column primary keys, and this is something we should really be doing in the future. But right now, it's only has to be not numeric, but a single column key. So we need to identify one because this is a flat file and there is no key in flat file. So we need to find that out. And in here, we have pub ID. I have to validate. It's unique. It's valid. So therefore, I can, it's valid. It's unique and no null. So therefore, I can use it. But it's still not correct because if you look at the icon, this is a fully spatially enabled data set. This one is not. It's like a table. So what else do I need? Well, I need to create an index. See here. Sorry. Initially, there was no recognizable geometry. We have two numbers. Well, they happen to be called log long and log lat. Well, how do I know they are coordinates? I know, but Studio does not, so I have to tell it. So say here. And well, we have some smart that recognize it says something like lat and long, so therefore that latitude, longitude. So okay, let's do that. So okay. So now it's creating a spatial index of this. Remember, it's important. If there is no spatial index, Studio will say, I can't do it. You have to create an index, but it will create the index for you if you want. So same thing for hotels. Need a data set, need a key column. So let's use hotel ID. Looks good. Validate, right? Apply. It's there. And similarly, need to create a lat long index. Like that, it's happening as well. And notice now pubs are really spatial because they have they are special, but they're also spatial because they have this little, map marker. Restaurants, they already have the map. How is that? Well, because in restaurants they are GeoJson, and in GeoJson I have something that says type geometry. So I know that these are the coordinates. So therefore, we automatically created a spatial type for that, and you automatically created the index as necessary. But still, Geojson does not have any concept of primary key, so we still need to select what should be our key, and our key here will be where see this one, restaurant ID. I could actually use any column as long as it's unique. Maybe restaurant name might be unique, although probably it's not. If like restaurant contain everything like McDonald's, there will be lots of McDonald's. Okay? So now we have our data. Let's see how we can view that data. So I'm going to select these three, not just shift click, right click or use the context menu from here and say create project. All right, so now I'm getting a new project created, and the project starts with a map that is centered on the world. On the very first version was actually centered on California every time, which is also the center of the world for Oracle, but might not be for you. So we said, let's put it this way. All right. And what I can do next is just drag these things. I can even drag, let's drag them one after the other. Let's start with pubs. So drag them on the map, and we zoom to Poland, Polska, because this is Polish. And here we see all my dots, all the pubs. I don't know how many there are, not many. I mean, a few thousands, but not like millions of them, really. Hotels, right? And then also restaurants. And we automatically pick some coloring. Now, these colors might not be too pleasing for you. We are using, in the first version, we used to be really like a red, green, blue, really strong red. Then we said, yeah, but no, that might be a bit, let's make it more pastel color. So these colors are okay on these maps. Sometimes the map would be too colorful underneath, and then you may use different colors here. And by the way, here also I should also point out that this is using by default a map called Map Tyler Bright, but I can choose another. Now there's also this one, which is like a dark map if you prefer. There's another one which is positron that is actually a lightweight map. You see gray, subdued gray. At the end, that's what matters. What matters is really that what we show on the map, not the map itself. No, the map is nice, providing content, but what I want to highlight these things. And so this is lightweight, and so does not have as many distractions as a full map. And you can even have third maps if you want. Or in my example here, I have, for example, Google defined as a provider. This will actually show me another photo from Google. Okay? So of course you have to set it up. We do not provide that by default. You have to set it up yourself, and you can do that by using this setup here. But that's not the goal here. Let's look at the data and let's turn off restaurants, let's turn off hotels and concentrate on pubs. And where are pubs? Well, you see a lot of pubs here. This is Warsaw, so capital city, lots of people, lots of pubs. Strangely enough, there are lots of pubs here in the southeast. Now, this is Krakow here, and I wonder why there are so many pubs here. No, lots of pubs here. This is Wrocław. It's a university town, or Krakow is also a university town, so maybe that's why there are lots of pubs. I'm not sure why there are so many pubs here. There must be some good reason here. This is Katowice, so I don't know why. But there are, maybe if there's a poll, somebody from Poland, he or she may explain why there are so many pubs. But okay, that shows where pubs are, but maybe I would like to have a better idea of the concentration of pubs. And so that's something I can do here by saying this. You see here the choice is actually a circle. Well, how about doing this, a heat map? All right, a heat map is based on the concentration of things on the ground. The more they are, the hotter the map. And so the hotter means red. Blue is cool, green is a bit warmer, then you go to orange, and then eventually to red. So we see there are lots of pubs here, so we can understand. And it's actually very useful for, like again, COVID cases, finding out where they are rapidly without really looking too much at the map. And as I zoom in, of course, this sort of changes automatically on the fly. So that's one way. And of course, if I zoom out, then it's total red. Another thing I can do here is actually use clusters. So clustering means I'm going to group to count how many pubs there are in a certain area and place a bubble there with a number of pubs. And so if I zoom in, if I plug in, then if I click, double click, etc., I zoom in, so that gets now spread into multiple bubbles. Right, so that's what I can do. These are the first two functions of what I can do with maps, with spatial data. So managing the data, uploading, and then doing nice maps. Okay, so let's, however, try and do, well, let me actually go back to the way things were, which means just not this, but just circles. And by the way, you can also do things like change the color of the circle of the symbol here based on some value. So you could imagine the kind of pub or the kind of restaurant. The restaurant per cuisine have different colors depending on different cuisine. You can also filter by cuisine, only see for the Chinese restaurant, the pizza places, or Japanese places. And you can also change the size of the button. So maybe for, I don't know, restaurants which have according number of stars, for example. The more star, the bigger the bubble, the button. here we don't do that. We just keep simple circles like that, because what we want to do next is actually to answer the question, well, where are the nearest pubs? Now let's find out. And for that, I'm going to turn also the restaurants on, and I'm going to put the pubs on top of the restaurant like that, so they are more visible. And what we are going to do is the following. We're going to pick a hotel. I'm going to pick this one. Oh, I don't know what it is. I need to maybe do that. Sorry, these are restaurants. I want to put hotels, not restaurants. And I want to, but it's the same anyway. So I wanted to get, I think this one. Yeah, I think it's this one here. But I selected the hotel, but I don't know what it is. To know what it is, I need to ask Studio to tell me. And that is done by this way. Interaction, tooltip, the name of the restaurant, hotel, and then also this that will show me the ID, the name, house number, street name, municipality, postal code, and phone number. So now when I click on this one, I know it's actually the Westin in Warsaw with all the details. So it is selected on the box, and now I want to find out which which pubs are within a radius of that particular hotel. So I'm going to here say start an analysis. Okay, so what do I want to do here? I want to return shapes which are within a specified distance of another. That's what I want to do. So, right? Select this, pub within distance from hotel. Let me make this, I think, not important, but let's call it like that, give it a name. So we are filtering pubs, and local long there are two columns. Which layer am I going to use? I'm going to use hotels. And you see, there is one selection. So I'm going to start from the one which is selected. I could have multiple hotels selected. And then I would find all the pubs which are within a radius of each of these. If I turn this off, then we'll do the process for all the hotels in Poland. So for all the hotels of Poland, we're going to run a query that says, show me all the pubs which are within this. And so on. So that's for like a many-to-many kind of correlation. And I can also say this. Well, I can also I can here say I want to include the key of the hotel. Now that would make sense if I try and find correlation between hotels and pubs for the whole country, because I see this pub is within distance of a hotel, but which hotel? Well, that will do that for me. So run it. I don't need that. So it's here. What? Pubs within distance. Oh yeah, sorry. Why is it show me that symbol? Well, because if I drag it on the map, it says, yeah, well, it's validated. Hold on. Oh, come on. What's wrong with this guy? No key column. Huh. Sorry about that. What's wrong with this? Oh, but pubs I've got. Oh, come on. What's wrong with this? Data set columns. Oh, no data to display. That's why it's actually empty. So I guess I made a mistake here. So let me get rid of this. Let me delete it. So delete it. Yeah, is it done? What's happening here? Let's try again. So I have to remove it from here. So remove from project, and then I can go and delete it. Okay, so now delete it. Yes, will be deleted permanently. So what mistake did I make here? Sorry about that. I made a mistake. What did I do? I said pubs. All right, spatial analysis, shape with a distance from another, pubs within distance. Okay, layer to be used as filter. These are going to be the hotels. Just that hotel. Oh yeah, I didn't specify a distance. That's why you should have told me before. Let's say if you want to walk there, let's say 1 kilometer, so 1,000 meters. All right, run. Okay, now that's much better. I shouldn't have let me do that mistake. That's anyway. So here we have a pubs within distance. So now I can add that to the map. Okay, yes, it has to now he's running the query, and so I have this guy here which has the pubs within distance. But the trouble is that it's hard to see, so I have to remove the pubs keep the hotels, but now where are these guys? Actually, I don't see them. That's a bit, oh, let's say pubs within distance. Maybe I need to change the color. Oh yeah, they are in this yellow color. So let's change this. Oh yeah, okay, let's make them in red. I'll put them in red like this. Like this. And now here we see them. Okay, so these are all the pubs which are within a radius of 1 kilometer from that hotel. What would be useful is actually to see that radius. So for that, I will need to do another analytic, which will be similarly pubs, hotels, spatial analysis, and this time we're going to filter, we're going to measure, transform, we're going to where is this? Combine, measure, calculate area. Oh, where? Hold on, hold this. How do I create this? The buffer? It's actually oh, there it is actually, create buffer. I didn't see that. Now, add a buffer specified distance, so hotel buffer on the selected hotel. No, there's only one. Distance 1,000. Actually, this is 10,000. We want to have it 1,000 meter, and there it is. Okay, so running. So now I have this, and I can take this here and as multiple mappable. Yeah, okay. So this one has actually multiple mappables. So I have to say the specific column. So I actually have to drag this. Okay, so this is my circle. So here, this is the buffer that is a 1,000 meter buffer around my hotel. So you see, that's how we will do these things. So we essentially build this stuff. We generate, we compute our buffers or distance, and we now know all the pubs which are within distance. We can also do something here like this, which is to add a table here, and now go back to data, and now drag the pubs within distance in here. So here are all the pubs, and when I click on this, it will be highlighted on the map as well. Okay? So that's what we wanted to do. Okay? There's more stuff we wanted to do here, but I think we are going to run out of time soon. So let's go back to the presentation. Okay. So how does this work under the hood? Like I said, we have types and functions, and in database, that's what it is. So we have a data type called SDO geometry. That's the one that contains all the information about, for example, for a pub location or for a hotel location. Well, it's a point, the coordinate system of it, the coordinates of the point. If it's an area, we'll have all the points that form the area. So the geometry, we need predicates in SQL to represent what we do. Now, this is actually something I may want to show quickly here. If I look at, for example, these pubs within distance, okay, properties, this is the query that's actually being generated, you see. And similarly for the hotel buffer, we'll see the code to the function which are done. So that's what we do here when we perform these things. So the predicates, you see SDO inside, this says something here where SDO within distance. So because it returns all the pubs which are all the pubs which are within a certain distance of that hotel. So SDO inside. The domain index, we need specific index. We call it an R tree structure. It's a rectangular tree of rectangles. Then there are functions like buffer, area, union to merge, etc. So this is all that we do. And so if we go back to, if we revisit what we've done before, so shapes having spatial relationship, that is one example. Here we look at vehicles and restricted areas, and we want to find out all the vehicles which are inside that particular area. And if you look at this here, that's what we do here. Now here it's actually within distance of something, all right? but that's what we do. So we essentially generate this code for you, so we don't have to do it. Shapes within distance. In fact, that's what we exactly showed you. So pub ID, phone number, for hotel name equals Hotel Indigo, within distance, pub location, hotel location. This says give me all the hotel, that's actually wrong here. That should be hotel in that pub location. 500 meters from that particular hotel, or restaurant which are closer, the nearest neighbors. How does this work under the hoods? Well, again, you can dig deeper. Our tables have a type called SDO geometry, like I mentioned. And in that type, we'll see things like, what is it? The point, a line, an area, the coordinate system, the projection, because the spatial data comes in multiple projections. Mostly we think about it as long and lat, but that's not the case. There are all sorts of different local projections. That's okay. Database doesn't care. And Studio even less. It doesn't matter. If your data is in some odd projection or local coordinate system, that's fine. Everything will be happening transparently. We'll transform things on the fly as you need it without you even noticing. So let's keep this. These are the inside of this object. And here is how you would do that in SQL, creating a new point. Here it's a city, could be a pub, could be something else. Now you specify using the SDO geometry constructor. This is a point, it's a 2D point, coordinate system, it's important, and then the X and Y coordinates, long and lat. Remember, this is always longitude, latitude. Then we need to create index of these things. Again, Studio did that automatically for us. We didn't have to do it, but if you do it manually, then you have to do it yourself. There are multiple data encodings we support. That's our geometry type, but there's also something called Geojson. Now, Geojson is well, essentially what we saw when we uploaded I think it was the restaurants. That was in Geojson, okay? Geojson point coordinates. There's also other things which are sort of more technical. It's geographic markup language, KML. Now, KML you should know because KML is used in Google Maps. They use KML. There's also this thing called well-known text, well-known banner that are a bit older. Okay, so an example of these things, how these things works underneath, this is finding all the parks which are inside the state of Wyoming. So the yellow area is the boundary of state of Wyoming, which happens to be a square or rectangle. And then there are parks, and the green ones are the ones which are inside that rectangle. Or you can find out, in this example, overlapping things. So here, this looks at all the states which are overlapped by Yellowstone. Yellowstone, I think, is the largest national park in the US, and it happens, most of it happens to be in Wyoming, but some of it is actually in I think this is Idaho, and this is going to be Montana. There's some small strip of that. So if you can find out which state overlap, then you can compute also the intersection between that polygon and the state and find out, well, how many square kilometers are in each state. That would just be other SQL. And of course, Studio lets you do these sort of computations. All these things within distance, find all the cities which are 100 miles of Boston. So you would do it like this, within distance. And the result would be like this. And what's the closest city to Boston? Well, it's Boston itself. Proximity queries, the nearest, that's what we are doing when we look at, for example, well, the nearest pub from a given hotel. But there's much more. Of course, database understands also things like a raster imagery, 3D buildings, point clouds, addresses. Some of these are understood by Spatial Studio. Some of them are not yet understood by Spatial Studio. And the story concludes with useful links. I think you will find them also in the chat to all the tools and all the things you can do, all finding information. Spatial database, so there's a URL that will take you there, will tell you about watch video. For example, there's a video here about specifically the example I gave you earlier on about the COVID exposure in Finland. Spatial Studio is there as well, so you can download it freely, use it, but you need an Oracle database as a repository. And there are also live labs available where you can learn about Spatial Studio. There's an intro to Spatial. There's one that tells you how to install Studio from Cloud Marketplace. So you can do that, and there'll be more in the future. We are working on more of these live labs, and that's I'm over now, except I guess I was
Thank you.
a bit longer than I thought, but I'm ready
No
to
problem. No problem at all.
questions.
No problem, Albert. We have 4 questions. The first one is about the data sets that you have. If there is any way that our attendees could get access to the data sets used for the presentation?
That's a bit of a problem because, yeah, if you look at the data sets here, I think, where are they? Move here. The data sets I'm using, unfortunately, you see, unfortunately, where are they? Where are my data sets? Oh, it's actually here. Yes. These things here, so which I didn't use, so provinces, counties, these are public domain. There might be still some little restrictions, source code adm.org. This is from here. This is actually data is coming from the here database, and we are not allowed to give that out. I'm sorry about that, simply because it is copyrighted data that belongs to the company code here. But you can find these sort of things through like OpenStreetMap and other sources. Right? It doesn't have to be this, or pubs, hotels, and restaurants. Essentially, if you search for it, you go. Google is your friend, and you look for example, a data set of pubs in Paris or restaurants in Paris. You will find sources which may be copyrighted or maybe not copyrighted. And of course, OpenStreetMap has all of this as well.
Okay. Okay, perfect. Thank you. And about licensing, so there are many questions about if is a Spatial Studio available with Oracle database, or if it's included with on-prem, with autonomous.
Okay.
So
right, Studio is a standalone tool. It must have a database because it only works with our database, but on its own right, it is independent of the database, and it's available. I think it's available. Did I indicate here? I didn't say where, but it's available online for download. So it is not. There's no license for it. You don't pay any license for it, and so you just either download and install on your local environment, like on your desktop. That would be the what I call the quick start. We call it the quick start. Then there's another one which you would need to deploy in an application server. I think it requires WebLogic. And there's a third way, which is to deploy it through the Oracle Marketplace. But itself, Studio is free. There's no license for Studio.
Perfect. I think that our attendees will love that. Thank you. And the last question that we have is related with Oracle Apex. Is there any free tutorials on a Spatial Studio with Apex? And if do we have any demos of Apex taking advantage of spatial features?
Apex, yes. Apex has had a spatial component for a while, but it was not really part of Apex. It was sort of I don't know. It's a prime, let's say, citizen of Apex. So it is a component which is in Apex. Are there any examples of that? I would have to look at the Apex website for that, to find out what there are. Are there any labs or examples of that? To be honest, I don't know. I don't know about it. But it is part of that.
I don't know, Shin, if you have some information about it too.
There actually is a pretty new Oracle Live Lab focused on getting started with maps and spatial in Apex that highlights some of the newest integrations. So that is available at the Live Labs website, which is entered in the Q&A box for Jose's question.
Perfect. And also we can also share it in our Slack channel. So guys, if you connect with us in our Slack channel, you will have this information too. Okay, perfect. Well, we are just running a few minutes late. Thank you so much, Alfred.
My apologies. I think there was one last question that was entered in the Q&A, if it's possible to squeeze that in.
Can Spatial use autonomous database with external tables? For example, keep the data in object storage?
can spatial be used with autonomous database and an
with external
table?
with external table?
That's a good question. Actually, I don't know.
We can answer it later also in
Yeah,
our
you see, the
channel.
one thing about that, the one problem here with that is illustrated a bit to the demos I made, where we take all the pubs that are within a radius of something. So that is a spatial query, and the spatial query, to be efficient, needs a spatial index. And if we put things outside database, there won't be a spatial index for filtering these things. So that's why I think it's probably possible for small amounts of data, but for large amounts of data, and large amounts here, we talk about hundreds of thousands, millions of things. If we focus on Poland, for example, I'm not sure how many pubs, how many bars and hotels there are, but they're not that many. I mean, it's maybe 10, 100,000, 200,000, these sort of things. But if we start having a global database, and we start having millions of things, or millions of businesses, or of moving vehicles, etc., then doing this query efficiently is important, because if we don't have a spatial index, in fact, spatial index are actually not really required. You could actually make, except Studio says I must have an index, and it says I must have an index because it knows that if you want to search for all the, for example, all the pubs that are within 1 kilometer of that particular hotel, and you have a global database of pubs and restaurants, and all the POIs that are like millions and millions or hundreds of millions of things. And the only way to do that with an index is actually to take each and one, read hundreds of millions of them, and then compute the distance and see, that would be very, very inefficient, extremely inefficient. So therefore, we must have an index, and the spatial index is only for data which is in the database.
Perfect. Perfect. Thank you so much, Albert. Thank you so much for your time. It was a great presentation, and it was great that you did something that it was unexpected, and then you fix it. That, I think, brings a lot of more value than you imagined. I think that was great. Thank you so much for your session, and the demo was very, very useful. And thanks to all attendees for attending this TechCast, and we are going to see you in the next one. Thank you so much, and have a nice day, everyone.
Thank you. Bye-bye.
Bye-bye.